So a Bronsted acid is just an acid that donates a proton. Hydrogen, if it loses an electron, it only is a proton because hydrogen is made up of electron and proton. So if you get rid of an electron, H plus, all that's left is a proton. So it donates a proton, and Bronsted base accepts a proton. For an example of this, HCl and water. So if you say HCl, well, HCl is an acid and a strong acid. After it's done donating a proton to water, whatever is left is called a conjugate base. So HCl, it donates that hydrogen, which is a proton. It donates it to H2O. That becomes H3 plus because before H2O was balanced. Because above it's 2 plus and 2 minus, right? It was balanced, but now after you added a proton, it's now H3O plus, and then whatever is left, because H is gone now, Cl minus, since whatever is left is called a conjugate base. So once again, that's the same thing, just HCl, it's an acid. When you donate that H, that proton, it becomes Cl minus. It becomes Cl minus, and that is called a conjugate base. So it's pretty much just the opposite. If it's an acid, it's called a conjugate base, whatever is left over. If, for example, if you have a base, it's called a conjugate acid. Because NH3, after it accepts a proton, it becomes ammonium, ammonia to ammonium, and then now you have NH4 plus, and that's called a conjugate acid. So, so just remember that Bronsted acid, it donates, bases accept, and pretty much the opposite. If it's an acid, it's a conjugate base. If it's a base, it's a conjugate acid.